Okay, let's dive right into this explainer. Today, we're going to look past all the euphoria in the stock market to uncover what is absolutely, without a doubt, the single greatest risk to the entire AI boom. Over the last few years, the market has just been on an absolute tear, right? Mostly driven by companies making these massive, world-changing moves in artificial intelligence. But beneath all those rising profits and sky-high valuations, there is a bottleneck, a very real single point of failure that the market, and honestly, potentially your long-term portfolio, is just kind of ignoring right now.
So here is our roadmap for today. We're going to cover 6 key areas. 1. The AI market's illusion. 2. The microscale hurdle. 3. Why Samsung can't compete. 4. The geopolitical threat. 5. The U.S. fab reality. And finally, 6. The investor warning.
All right, starting with Section 1, the AI market's illusion and who actually makes the chips. To really understand the risk here, we have to first understand who actually controls the hardware that's powering this entire revolution. Yes, the stock market is surging, but it is incredibly concentrated. The Magnificent 7 tech stocks, they now account for literally over a third of the entire S&P 500 index. Investors have been flooding money into just these specific companies. But as you can imagine, this creates a pretty precarious situation for long-term investors. Because these top companies are so deeply intertwined with the AI boom, if a problem hits them, it wouldn't just be an isolated little hiccup. It could effectively bring the whole market down like a giant house of cards. And the undisputed king of this current boom is, for sure, Nvidia.
Nvidia recently hit a staggering $4.5 trillion valuation. I mean, they account for over 7% of the S&P 500, all by themselves. And investors are giving them a price-to-earnings ratio of right around 50. To put that into perspective, what that practically means is that after 50 years of their current performance, the business would finally earn enough to make back your money. That is a sky-high valuation, and it demands relentless, uninterrupted growth. Everybody wants Nvidia's highly desired AI chips, the H100s, the B200s, but there is a massive misconception about where these highly coveted chips actually come from.
So here is the really fascinating reveal. Companies like Nvidia and Apple, they're not actually chip makers. They are chip designers. Nvidia's engineers design the incredible architecture, the memory layouts, the software stacks, the power efficiency, but they do not manufacture their own physical products. They just draw the blueprints. The exact same thing is true for Apple. The company that actually manufactures the world's most desired chips is TSMC, the Taiwan semiconductor manufacturing company. Just one single company manufactures 80 to 90% of these advanced chips.
Moving on to Section 2, the microscale hurdle, and exactly why TSMC has a monopoly.
Now you might be thinking, well, if a problem comes up, we can just swap manufacturers, right? Just take our designs to another factory. Well, zooming into the micro-level engineering shows exactly why we absolutely can't just do that. The chips that Apple and Nvidia are designing right now, they're built on 3 and 4 nanometer chip generations. For a quick sense of scale here, a single human hair is roughly 70,000 nanometers thick. That means the transistors powering the entire AI revolution are 3,000 to 4,000 times smaller than a piece of your hair. To pack these mind-bendingly tiny transistors onto a chip at this scale, it requires a level of precision that honestly borders on science fiction.
And to even attempt to make these chips, you need highly specialized machines. There's only one company on the entire planet that makes them, ASML, based over in the Netherlands. Each machine costs around $300 to $400 million, and there are only a few hundred of them in existence. But here is the real catch. Even if you somehow throw $400 million at the problem and buy a machine, you still can't make a 3-nanometer chip, because that money doesn't buy you the decades of operational experience, the customized software, and the ultra-specialized supply chains that you need to actually run it. TSMC has spent decades perfecting this incredibly specific recipe.
Which brings us to Section 3, why Samsung can't compete and the yield problem.
So a question that comes up a lot is, if TSMC has this locked down, why can't Nvidia just send their orders to a massive competitor like Samsung, who also has some of these machines? The crucial point here is that Samsung, who is literally the next most advanced foundry in the world, still struggles with huge defect rates at these microscopic scales. During manufacturing, it's normal for some chips to come out defective, but Samsung has experienced significant yield issues. We're talking sometimes facing a 20% yield loss on their 4-nanometer processors. Imagine producing a $30,000 GPU for Nvidia or a $200 smartphone processor for Apple at a massive scale and having to just throw away 20% of your product. That is a catastrophic profit loss for any hardware business. In fact, Nvidia learned this the hard way back during the pandemic when they used Samsung's 8-nanometer process for their RTX 30 series GPUs. The yields were so poor that Nvidia basically ran straight back to TSMC for the next generation.
And that leads us to this rather chilling reality. If something happens to TSMC, you cannot swap them out. There is no viable backup plan. There isn't some ready-to-go fab in Texas that Nvidia can just rent out to keep production flowing. If TSMC goes offline, the entire global tech supply chain literally hits a brick wall.
Let's look at Section 4, the geopolitical threat and Taiwan's precarious position. Let's zoom back out to the macro level and impartially assess the supply chain risks surrounding the island of Taiwan. Because this technological monopoly, it sits directly on top of a major geopolitical fault line. And we are neutrally reporting the data points coming from U.S. intelligence and global observers here. U.S. intel assessments suggest that Chinese forces are preparing to be capable of invading Taiwan by no later than 2027. Observers have noted China testing specially designed landing ships, and they're building 70 new commercial ferries capable of transporting armored vehicles, scheduled to be done by the end of 2026. On top of that, we've seen large-scale military drills conducted in the waters directly surrounding Taiwan. Now again, we are not predicting an outcome here, but looking purely at supply chain security, the entire AI industry is currently propped up by facilities located exactly where these geopolitical tensions are the highest.
And if a conflict were to occur, here is the immediate chain reaction. It's really not just about physical damage to the factories. TSMC's facilities depend entirely on global inputs, high-end machinery, specialized chemicals, and software from the US. If an invasion occurs, those supply lines are instantly cut. Even if the factories were left completely physically intact, the TSMC fabs would be dead in the water. Furthermore, there are widespread reports that the US actually has contingency plans to remotely disable the factory tools so they couldn't be utilized by an occupying force. The flow of advanced chips to the West would stop completely. The immediate economic consequences for global markets would be, frankly, unprecedented.
Which brings us to Section 5, the U.S. fab reality and those delays in Arizona.
But hold on a second. Isn't there already a solution in motion? What about the U.S. spending billions through the CHIPS Act to build brand new TSMC fabs right in Arizona? Well, it is true that TSMC is building facilities on American soil, but just because you pour the concrete doesn't mean you can instantly pump out the world's most advanced chips. The timeline tells a very different story. The first Arizona site was originally targeted to start producing chips in 2024. That's now been pushed back to late 2025 at the earliest, and the second site, that might not be ready until 2028. So this clearly proves that bringing chip manufacturing onshore is absolutely not an overnight fix.
And honestly, the delays make total sense when you realize that a fabrication plant is infinitely more complex than a traditional factory, like a car assembly plant. These are straight-up sci-fi level facilities. The air inside a clean room is purer than a hospital operating room. Workers have to wear full-body bunny suits because one single microscopic speck of dust can literally destroy millions of dollars worth of silicon wafers. Beyond that physical complexity, there's a severe lack of local talent. TSMC actually found that the US workforce lacked the highly specific expertise they needed, which forced them to literally fly engineers over from Taiwan. And finally, and this is a big one, when these plants do eventually open, they'll only be producing 4-nanometer chips, meaning they will already be a generation behind the latest 3 and 2-nanometer technologies required by the newest Nvidia and Apple designs. It's going to take a decade to truly replicate the talent and the ecosystem needed for true state-of-the-art independence.
Let's wrap things up with Section 6, the investor warning and the economic flow-on effect.
Okay, let's tie this all back to what this actually means for you as an investor tracking these massive AI valuations. This right here is the true definition of a single point of failure in our modern economy. Removing one tiny island off the coast of Asia effectively halts the infrastructure of the biggest tech giants on the planet. Think about the domino effect. If TSMC stops, Nvidia stops. If Nvidia stops, the AI hardware fueling Amazon, Microsoft, Tesla, Meta, and Google just completely freezes. This dynamic gives enormous strategic leverage to whoever controls that supply. It's very similar to how controlling rare earth metal refining provides massive geopolitical negotiating power today. So I want to leave you with this final thought to consider the next time you're looking at the euphoric stock market or maybe reviewing your own long-term portfolio. If the physical blueprints of the future, the raw hardware required to power the entire AI revolution, are completely dependent on the stability of one small contested island, just how secure are the trillion-dollar valuations of today? It's a fragile reality, and it's one that we all need to be paying much, much closer attention to.